Yay, calculus. All right. We have three graphs in number 61. We need to figure out which one is distance traveled, which one is velocity, and which one is acceleration. It does say distance traveled, not displacement. So I'm going to go with this one for distance traveled because we have to actually get someplace. You know, we have to increase. So I would kind of assume that that's distance. And so, assuming that this is distance, velocity would be the derivative. So we just need to do the derivative graph of this. So the derivative here is about 0. We go up a bunch, and then we come back down to 0. And both of these have 0 here, but we increase and then decrease. So that's this one, whereas this one increases, decreases, and increases. Let's go for distance here, velocity here. We'll double check that this is the acceleration curve for this, which would be the first derivative. We start out about 0. We increase, go down to 0, and then we have a negative slope as we get slower, and it goes back there. So so 0, increasing, sort of get a little slower and slower. 0 here, now we're negative, and now we're 0 again. So let's call this acceleration. Distance, velocity, acceleration. All right, 62. Let's take a look. Let's do a sketch graph of continuous function f with f of 0 equals 5, f prime. All right, so we know that we want to sketch f of 0 equals 5 is our first clue. And our derivative function, which will tell us the slope, is in two parts, -2 and -0.5. And that is when x is greater than 2 and less than 2. I have those backwards. X is less than 2 and x is greater than 2. All right, so f of 0 equals 5. Nice point. And it looks like for all x less than 2, our slope is -2. So that's a nice straight line. Derivative of that. So we go a nice straight line up to 2. So let's see, this is 1, this is 2, this is 3. So this is going down by 2 until we get 2. So if we're at 3, go over 1, we're at 5, go over 1, we're at 3. Let's see. 1, 2, 3. We're at 3. And a slope of -2. And here at 2, we're probably over here at 1. So this continued indefinitely, this f. We have a slope of -2, so that's down 2 over 1, down 2 over 1. And then for x greater than 2, our slope is -0.5. So that means that for every 2 we go over, we'll go down 1. So that would be 4 that we'd hit, like that. And we need a continuous function. All right, so this just keeps on going like that. We could satisfy these requirements and have some point up here, but we were specifically told this was a continuous function, so that means that we need the limit both sides be the same. I think that's it, really. This is the point 2, 1. So we started here, use the slope this way to make a line. So f of x, we could actually write out the piecewise function that would look like this. We know we intercept 5 here. So for x less than 2, talking about -2x plus 5, right? Slope of -2 and intercept of 5. And then for this one, we have -0.5x. And where we would hit, we can figure it out. Y equals mx plus b, right? And we go through the point 2, 1. So that's 1 equals our slope, -0.5. X is equal to 2 plus b. And so that'll be 1 equals -1 plus b. So that means that b equals 2. So plus 2 for x greater than 2. And there you go. So we're continuous. We can put a line underneath either of these. Not both. We don't want to double define. So the section was called curve sketching. I realized that last graph was 2 straight lines in the corner, but still technically a curve. Just curve of 0. Let's see here. 63. So it's the graph of a continuous function. All right. So same bits, just slightly more complicated. We do need to be continuous. We do need, so continuous. F is continuous. First thing we know. Second thing we know is that at -1, the value of f is 2. And that all of our slopes are, let's see, -2, 1, and -1 on the intervals of x less than 1, x from 1 to 4, and x from 4 to 6. All right, so we'll start out with this graph here, and so let's use 1, 2, 3, 4, 5, 6, 7, 8. And f of -1 is 2, so it's 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's see, that's 2, 4. All right. So let's begin here. I'm given a point. Let's sketch that first. So f of -1 is 2. So we go through that point. For all x's less than 1, our slope is -2. So that means we drop 2 for every 1 we go over. So that means go over 1, we're down 2. Go over 1, we're down 2. Continue that up. This is the line of x equals -2x. We go right through 0. So we're sitting here, need to be continuous, so we'll put in our point. Excuse me. All right, so now our slope is 1, 1 to 4. So we start here. So up 1 over 1, up 1 over 1, up 1 over 1. Go to there. So this line would hit there, so that's f of x equals x minus 3. That line. And then -1 from 4 to 6. 5 and 3. Oh yeah, get some orange. -1, so we're going down 1 over 1, down 1 over 1. From 4 to 6, no, equal to or less than. So that stops there. So there's our continuous curve. Is f of x equals -x. Where did we hit there? If we're at 4 at 1, then we went over 4, we go up 4, so we've got 1, 5, so plus 5. That's our curve to sketch out. It doesn't ask us to do the whole piecewise function. We can do it as an exercise if you like. Move on to 64. Cool. Near the last page. Which of the following statements could be true if the second derivative of x equals x to the 1/3? So we are given in 64 that f double prime of x plus x to the 1/3. All right, and it gives you all four. So we can just take the derivative of each one if we like. So in number one, or I rather, all that in one, f of x equals 9/28. 9/28 x to the 7/3 plus 9. So if we go ahead and take our first derivative, I, 7/3 times 9/28, that goes to 4, that goes to 3. So that's 3/4 x minus 3/3, 4/3, goes to 0. And then f double prime of x, 4/3 times 3/4 is just 1. And x minus 3/3 is going to be 1/3. So this could certainly be true. So I is a go. Two. Make sure I'm not running out of time here. Okay. Pardon me. Oh, they give you the first derivative of this one. That's kind of nice. First derivative is 9/20 x to the 7/3 minus 2. Which means that one derivative there afterwards, that's going to go 3/4 again. And the 2 goes to 0. So 2 is out. No 2. Third one is going to be f prime of x equals 3/4 x to the 4/3 plus 6. So we take our next derivative. 4/3 times 3/4 is 1. X 4/3 minus 3/3 is 1/3. That goes to 0. So 3 is a go. What remains to check is 4. And 4, well, A, B, C, and D, that removes our chances. But good. Number 4 is that f of x equals 3/4 x 4/3 minus 4. And our first derivative of x is exactly what we're looking for, because that'll go to 1, x to 1/3, that'll go to 0. Our second derivative of x is going to be 1/3 x to negative 2/3, which is not what we're looking for. So 1 and 3 are only choices, and so that'd be D. Would be our correct answer.